You built two separate VNETs, maybe one for production and one for development, maybe one for your application tier and one for shared services. Now they need to talk to each other privately, without going out to the internet, without a VPN tunnel, without any shared public infrastructure. That is what VNet peering solves, and it does it in a way that is fast, reliable, and built directly into Azure's backbone network. VNet peering is a mechanism that connects two VNets so that resources in both can communicate with each other using private IP addresses. The traffic between peered VNETs travels over Microsoft's private global backbone network. It never touches the public internet. It never leaves the Microsoft infrastructure. This means you get the same low latency and high bandwidth that you would get if the resources were in the same VNet, but with the administrative and security isolation of having them in separate VNets. There are two types of peering. Regional peering connects VNets in the same Azure region. Global peering connects VNets across different Azure regions. Both types work the same way from a configuration standpoint, but global peering has different SLA guarantees and different cost characteristics because the traffic is traversing Microsoft's long-distance backbone infrastructure. Here is something critical that the exam tests constantly. Peering is not transitive. Read that again. Peering is not transitive. If VNETA is peered with VNETB, and VNETB is peered with VNETcetera, VNet A cannot automatically communicate with VNet C through VNet B. There is no automatic path inheritance. VNet A and VNet C are strangers to each other unless you create a direct peering between them or route traffic through a gateway or network virtual appliance that is explicitly configured to bridge the connection. Let me give you the analogy that makes this permanent in your memory. Imagine 3 apartment buildings on the same city block. Building A and Building B have a private covered walkway between them. Building B and Building C have their own private covered walkway. Now a resident of Building A wants to visit someone in Building C. Can they walk through Building B using both walkways? No, the walkways are private. They only connect the buildings they were built between. To get from Building A to Building C, that resident has to go outside to the street, or you have to build a new walkway directly between Building A and Building C. That is non-transitive peering. The connection only works for the two VNets that the peering was created between. Now here is the configuration detail that trips people up. Peering is a two-way handshake. You cannot create a one-sided peering and have it work. VNet A must initiate a peering to VNETB, and VNETB must accept or initiate a peering back to VNet A only when both sides of the connection are configured. Does traffic actually flow? On the Azure portal, this happens somewhat automatically when you have access to both VNets, but in real-world scenarios where different teams or different subscriptions own different VNets, one team creating the peering on their side is not enough. Both sides must be configured. The address space constraint is the other exam favorite. You cannot peer to VNets if their address spaces overlap. If VNet A uses 10.0.0.0/16 and VNet B also uses 10.0.0.0/16, the peering will fail immediately. Azure has no way to route traffic when it cannot determine which VNet owns which IP address. Address space planning, which we covered in the subnet lesson, matters precisely because of this. If you ever plan to peer VNets, and most architectures do, you must ensure your address ranges do not overlap from the beginning. One advanced feature worth knowing: gateway transit. If VNet A has a VPN gateway and VNet B does not, you can configure VNet B to use VNet A's gateway to reach on-premises networks. This is called gateway transit. VNet B enables the option to use remote gateways. VNet A enables the option to allow gateway transit. When configured correctly, VNet B can reach the on-premises network through VNet's gateway without having its own. This is foundational to the hub and spoke topology we will cover later in the series. Direct connections only, no overlapping addresses. Both sides configured, gateway transit when needed. Day 5 done. See you tomorrow.